TASH process gas compressor with variable speed drive, VSD. Inputs, outputs, control, monitoring, and shutdown. A process gas compressor with a variable speed drive, VSD, is commonly used in refineries, chemical plants, and gas pipelines to compress gases at variable flow rates and pressures while maintaining energy efficiency and system safety. Below is an overview of how inputs, outputs, control, monitoring, and shutdown mechanisms function in such a system. Inputs. 1. Process inputs. Inlet pressure from the gas feed system, pressure transmitter. Discharge pressure of the compressed gas, pressure transmitter. Flow rate of the gas entering and exiting the compressor, flow meter. Inlet gas temperature, temperature sensor. Gas molecular weight or density, gas analyzer for density correction. 2. Electrical and motor inputs, motor voltage and current feedback from motor control center. Motor speed, feedback from encoder or tachometer. Power consumption and efficiency, power analyzer. 3. Environmental and auxiliary system inputs, lubrication oil temperature and pressure. Compressor casing and intercooler temperatures. Shaft displacement or vibration levels, displacement probes or vibration sensors. Differential pressure across filters and separators. Differential pressure transmitters. Outputs. 1. Control outputs. VSD control signal for motor speed adjustment, analog or digital output. Control signal to gas recycle valve, modulates to control flow during low demand or startup. Signal to auxiliary systems such as oil pumps, coolers, and gas seal systems to maintain optimal conditions. Discharge valve control signal for pressure regulation or bypass control. 2. Alarms and indications. Local and remote displays showing flow rate, pressure, temperature, and speed. Alarm indicators for abnormal operating conditions, e.g. rising vibrations, low lubrication oil pressure. 3. Trip signals. Command to trip the compressor motor in case of critical failures. Shutdown signals to auxiliary systems, e.g. stopping seal gas system or lubrication pump during a controlled stop. Control functions. 1. Speed control. The VSD adjusts motor speed to maintain the set pressure ratio or flow rate. PIDE controllers are used to regulate VSD output based on feedback from flow and pressure transmitters. 2. Flow control. A gas recycle loop is used to modulate the flow during low demand periods. The compressor speed and discharge valve positions are adjusted to prevent surges and ensure stable operation. 3. Anti-surge control. An anti-surge control system ensures that the compressor does not operate in the surge zone, which could lead to damaging vibrations. Surge is prevented by opening a recycle valve when the flow rate falls below a safe threshold. 4. Interstage cooling control. The cooling system for multi-stage compressors regulates the interstage gas temperature to maintain efficiency and prevent overheating. Cooling water or air coolers are automatically modulated based on temperature feedback. 5. Startup and shutdown sequences. During startup, the VSD gradually increases speed while the gas discharge valve and recycle valve are controlled to avoid pressure surges. In normal shutdowns, the compressor speed is reduced gradually and the gas is vented or bypassed to avoid sudden flow stoppages. Monitoring. 1. Local monitoring. Instrumentation near the compressor provides visual indicators for pressure, flow, and temperature. Local Human-Machine Interface, HMI, screens display real-time trends for operational feedback. 2. Remote monitoring. SCADA or DCS systems provide real-time compressor performance data, enabling centralized supervision. Historical data logging supports condition monitoring and predictive maintenance. 3. Alarms and warnings. Early warning alarms are issued for conditions such as high vibration levels or abnormal temperature increases. Advanced diagnostics provide status reports on bearing health, lubrication quality, and potential misalignment. Shutdown functions. 1. Automatic trips. High discharge pressure trip to prevent overpressurization. Low suction pressure trip to avoid cavitation or starvation. High casing or motor winding temperature trip to protect the compressor and motor. High vibration trip indicating misalignment or rotor imbalance. Low lubrication oil pressure trip to prevent bearing failure. High gas seal leakage detection to avoid process leaks. 2. Emergency Shutdown ESD, manually triggered via local or remote emergency shutdown stations. immediately stops the compressor and activates all safety interlocks, including closing isolation valves and stopping the motor. 3. Controlled shutdown, used during routine maintenance or planned stops. Involves gradually reducing compressor speed, maintaining gas flow through the recycle line until the system reaches a safe state. The lubrication and cooling systems remain operational during the cool-down period to prevent thermal shock. Safety and environmental controls. Gas detection, continuous monitoring for flammable or toxic gas leaks around the compressor area. Seal gas system ensures that the process gas does not leak from the compressor shaft seal by maintaining a barrier gas. Emergency venting. Pressure relief valves vent excess gas to a flare system or safe location to prevent overpressure conditions. Vibration and temperature monitoring. Redundant vibration probes and temperature sensors monitor critical components, ensuring early detection of potential failures. The combination of advanced monitoring, control, and shutdown systems ensures that the process gas compressor operates efficiently and safely, even under variable load conditions. The integrated anti-surge control and safety interlocks protect the compressor from mechanical damage, ensuring high availability and reliability in critical process operations.